This is a hardware overview of our 4-channel solid-state relay controller. This is a ProXR Series controller with a USB interface module installed. We have 4 solid-state relays on the board. These particular relays are for AC switching applications, but we do have DC relays if you need to switch DC loads. There's 2 connection points for each relay, allowing you to turn things on and off through these connections. Now keep in mind that AC and DC solid-state relays are very different. AC relays are required for AC applications, and DC relays are required for DC switching applications. Also, AC solid-state relays work a little bit differently than a mechanical relay. They do not actually make a connection between these 2 connection points. They actually make an electronic connection, and that electronic connection requires that you run power through the controller. In other words, if you hook this up to a meter and you try to turn these relays on and off, the meter isn't going to do anything. However, if you were to connect a light bulb up to it, such as a 100-watt light bulb, and connect it through these connections, the relay would work. And that's because the relay has to have a load flowing through it in order for the relay to turn an external load on or off. This relay controller also has 4 onboard LED status lights that let you see the on-off status of each of these relays. Also included are 8 channels of analog to digital conversion. A to D converters are used for reading external sensors such as temperature, light, humidity, or any other kind of sensor that generates a 0 to 5 volt output. A to D converters on this controller are capable of reading voltages with 8-bit or 10-bit resolution. One of the rules of A to D converters is that they must never be left floating. In other words, they should never be disconnected and just working without any type of connection. So to get around that problem, we include 10K resistors that can be pulled up or down through this jumper. So if you install this jumper in the up mode, all of these inputs are pulled high through a 10K resistor. Or if you connect the jumper down to the down mode, all of these inputs would be pulled to ground through the 10K resistor. And that'll keep the inputs quiet while still allowing you to use them with a voltage source. A to D inputs can also be mapped to directly control the relays. So if you need a hardware switch to directly turn relays on and off, you can connect those switches to these A to D inputs, and then through our base station software, you can configure what functions the inputs perform on these relays. Also included on this controller is an integrated temperature sensor. This temperature sensor is connected to the temperature sensor output. This output can be connected to any of the A to D inputs through an external wire. And that allows you to use that input to read the onboard temperature or the ambient air temperature. Also, some sensors require a small voltage, such as a 5-volt power supply, to make them work. So for your convenience, we included an auxiliary 5-volt output on this controller that allows you to power up small external digital circuits. We also have the ability to power this controller through the 2 terminal blocks shown here. You actually have the ability to power it through the terminal blocks or through the barrel connector. Either one will require a 12-volt DC power supply. In this particular video, we're powering it through the barrel connector for convenience purposes. This controller also has a program run jumper. Normally this jumper will stay in the run mode. However, if you need to make special settings, changes to the settings of the processor, you can change this jumper over to program mode and then make those changes. Also, if you ever lose communication with the controller because of incorrect settings, you can recover those settings by switching this jumper over to program mode and then powering up the controller and running our free base station software. That will allow you to recover settings in this controller, and when you're finished, you can switch it back to run mode for daily applications. We also have a busy ready LED for this controller. Normally the ready LED is illuminated. However, when a command is received by the controller, the LED switches from ready to busy. And then when it's finished, it switches back to ready. This is a very fast operation, as this controller can process commands very quickly. Here we have a USB module installed. This module is removable, but when you use the USB module, This module will establish a virtual COM port connection with your computer. That will allow you to send serial commands to this controller to control the relays or read the A to D inputs. You can easily remove this module and replace it with other communication technologies such as RS-232, Bluetooth, Ethernet, wireless, or Wi-Fi. If you happen to be using the Wi-Fi connection, we have an ad hoc jumper that will put the Wi-Fi communication module into ad hoc mode. That about covers it for this 4-channel solid-state relay controller, but if you have any questions, please let us know. We would be glad to help you out. Thank you.